Alright, let's look at the first question. When I go through the question, I'll give you the idea and then I'll give you the solution. I'll teach you how to solve it on the spot. Okay, first of all, let's look at the first question. For loci, listen, silence needed. Okay, now for loci, this C is a bit short. Okay, but never mind, I prefer it this way so you can look at the screen. Okay, now for loci, silence, yeah. You have to identify the three things, right? Perpendicular, bisector, circle, and half line. If you look at this looks like a circle. This is actually a perpendicular bisector. The thing I need to caution you is, if it's mod z, always put 0 plus 0i, if it's just alone by itself, so that you know it's between 4 and 0. Okay? Now once you have done that, you start sketching. But be careful because he says that he wants the locus representing the point z. So, this is the answer. Alright? This is actually where we want. Tell them this is the locus of z. Done? Okay, we finished first question already. Let's go on. Isn't this the first question? Alright. Alright, simple. Right? Draw a circle. It's inside the region. Okay, let's go on to the second question. Okay, silence. Anyone have a problem? You are okay? Now, you know why I finished the first question very fast? Because the next one will be more difficult. And the last one is the nightmare. Okay? Let's go on. Okay, now this one I'll be slowing down. Same thing. Identify what it is. This is a half line. There are two of them. Between pi over 2 and 3 pi over 4. Negative 3 pi over 4. And this is a circle which is inside the circle. Because I cannot draw circle well on the screen, I have a preset circle for me here. Okay, now I'm going to teach you how to draw the half line. He wanted pi over 2 and 3 pi over 4. Take note, this is the same as argument z minus 3 plus 3i. Okay? So let's identify where is my argument 3 plus 3i. Is it here? I put open circle. I draw the positive real axis. This is 90 degrees. This is pi over 2. Okay? The other one is negative 3 pi over 4. I measure negative 3 pi over 4 roughly is here. This is negative 3 pi over 4. But then you'll be in a dilemma. Does it pass through the origin? How do you test? So, this is actually argument z minus 3 plus 3i equal to negative 3 pi over 4. How do I know that it passes through the origin? How do I test? Anyone? You substitute in the origin inside here. You put z as 0 plus 0i. So what happens? It becomes argument 3 plus 3i. Can you check whether does that become negative 3 pi over 4? Yes, right? So that's how you test. Because sometimes when you draw, you're not sure. You do not know whether it actually passes through. So the best way is to put in the point to test. Okay, now once you get that, let's revisit the question again. He says, illustrate both relationship in the Argand diagram. You need to shade the overlapping region. In this case, it will be here. Okay, so this is the first part. So we okay? Okay, once we have done that, let's go on to the next part. Okay, you need to copy down first? Yeah. If you look at your question, the next part says find the greatest value of this. They want you to find the greatest value of this and they want you to find the least value of this, right? Now, what does this mean? Interpretation. This means z minus 3i. Okay? What he's saying is this. If I put in z is actually my shaded region. When z is going into the equation, minus plus 3i, which is minus 3i, the distance between z and negative 3i. What is the greatest distance? So first of all, whenever you see such a question, the first thing that you think about is locate for me negative 3i. But before you actually start locating, please put it into the form first, which is mod z minus a, that form. Now let's locate negative 3i. Okay, let's say, I think my diagram is too small, so negative 3i should be here. Okay, let's say that this is negative 3i. Okay? Now, you know that I need to draw a line from negative 3i all the way to z. And for me to get the longest distance, I have to pass through the center of the circle. Correct? The blue line represents the longest distance. Agree? But there's a problem. The problem is we need to get the values. We cannot just simply use Pythagoras theorem because I do not know where he ends. So we got to improvise. First of all, let's look at this. What is the distance of this? This is just the radius, which is 2. Am I right to say that? Using Pythagoras theorem, can you see that this is actually 6 and this is actually 3? Am I right? So this part here basically is square root 6 squared plus 3 squared. Can you all follow? So square root 6 squared plus 3 squared plus 2 will give you the entire distance from negative 3 all the way to the extreme of z. Cheryl? Okay, the shortest distance, similarly, this is the shortest distance. Correct? This is the shortest distance. Now, shortest distance, same thing. You take the whole length, which is your square root 6 squared plus 3 squared minus away 2. Okay, that will give you the shortest distance. So, let me write it out. Yeah. Okay, that's the answer. Okay, part 3. Finish copying. Yeah, let's revisit the question. Find the least possible value of argument z. Before we go on, you need to understand what's argument z. Means argument z minus 0 plus 0i. Identify where it is to z. So if you go forward, now let me revisit my diagram again. Yeah. I'm going to take away, I'm going to erase things. Okay, let me see. Let me erase this. Erase this. Okay. And then I'm going to reconstruct this again. This is dotted. Okay. Now, where's argument z? Argument z is here. Okay. If you draw the positive real axis, which is here, the minimum angle that can ever be formed must be a tangent to the circle. Right? Must be a tangent to the circle. That will be the smallest angle wave from the positive real axis to the shaded point. And that tangent would have a 90-degree feature here. Right? Because it's a tangent to the center of the circle. So now, they want to find this angle. Can I call this alpha? Which is what I want to find. Okay? And let me call this theta. Okay, let me see. Maybe I should call this. Let me change the wording. Let's call this whole thing as alpha and the small one as theta. We found out that this dotted red part here is actually root 18 from earlier. Okay? We know that the radius of the circle is actually 2. If you want to find the angle theta, isn't it sine theta equal to opposite over hypotenuse? Is it clear? Right? Just know, sine theta is opposite because right angle triangle. So sine is opposite over hypotenuse. I'll get theta already. Now, so theta is in radian. So theta will be equal to 0.49088. Let's say I use this value first. Now, I need to find out another angle. It's called alpha. But to get alpha, I need to get this triangle out. And this triangle has a length of 3 units, right? And 3 units respectively. Which means that tangent alpha is equal to 3 over 3, which is 1. So alpha equal to pi over 4. Right? So if alpha is pi over 4, theta is 0.49088, definitely this angle here, which I want to find, which is the smallest, which is argument z, the least argument z, which is this, is simply alpha minus theta. Correct? Okay, so let me tidy this up for you. Yeah, so the answer is this. So I found my sine theta, which is 2 over root 18. Theta is 0.49088. So argument z is equal to tangent inverse 1, as I mentioned just now, minus 0.49088, which is pi over 4 minus 0.4988, which is equal to 0.295 radian. That's the answer. Everyone okay? Okay. I still got 15 minutes, right? Okay, let's go on. We have only 2 more questions. I'm really optimistic about life. That's good. Okay, let's go on. Now, finish copying. 7.5 minutes per question. That's ridiculous, but never mind. Okay. Here, let's go on. Number 6. For number 6, he asks you to find the Cartesian equation and then sketch the loci. Now, basically, if you need to talk about Cartesian equation, you need to replace z as x plus iy, and then you solve it. So let's look at how we can solve this. Wait, okay, let me see if I can bring this down. Alright, let's begin solving. So you start off with this, mod z squared equal to 2imz. What's imz? Imaginary, right? Imaginary x plus iy, imaginary z is y. So you get, this is 2y, this is x plus iy squared, which gives you square root x squared plus y squared equal to 2y. You simplify this, you get x squared plus y squared minus 2y equal to 0, and this will give you a circle. If you remember, it's x squared plus y minus 1 squared equal to 1, and becomes x minus 0 squared plus y minus 1 squared equal to 1. Radius 1, 0, 1. So this is your circle. See, I finished half already, the question. Okay, let me scroll down a bit. This is your circle. You are supposed to draw that. Okay, those that need this. Okay, once you have done that, now we're going to solve the next part. Find the greatest possible value of argument z plus root 3. You must convert this to this, right? And identify where is negative root 3. So if you go to the question, negative root 3 is actually here. And if you want the greatest, means that you need to have, because this is your loci, right? This is the greatest. Okay, so it will be a tangent again to your center. I'm going to draw this so that it's easier for you to see. Okay. Now, if you look at it by symmetry, I need this angle. This is what I want. Okay, this is what I want. I have two triangles there. Because it's a tangent, This is also a tangent, so therefore this is also 90 degrees, right? So if I can find this angle, let's call this alpha, and I just multiply by 2, will be the greatest value of argument z plus root 3. So let's see how we can find this. This is 1 unit, this is root 3 unit, correct? So you know that, let's call this some points here. Let's call this C, B, A, and let's call this the origin. So tangent angle CAO is equal to 1 over root 3, right? Tangent is opposite over adjacent. Therefore, angle CAO is equal to pi over 6, right? Which is alpha, which is what I call alpha. So therefore, argument z plus root 3 is equal to 2 alpha, which is 2 pi over 6, which is pi over 3. Finished. See? 5 minutes only. Okay. Do you think we can be on time? Oh, definitely. I completed the question, but do you understand? Understand? Okay, now let's go on. Copy first. We see it, okay? Yeah. Alright, let's go on. The last question. Okay, now, the most difficult part about this question is constructing the loci. The calculation is easy. First of all, let's study this loci. Yeah? Let me break it down for you. For part 1, basically it's a circle. Center 2 plus I, radius 2. The other fellow is a perpendicular bisector with a region because of the inequality centered about 2 plus I lesser or equal to IZ plus 3. But the IZ plus 3 is a problem because that is not a format that we have in perpendicular bisector because I need to be Z plus A, right? So we got to take out the I as a common factor. So how do I deal with that? IZ plus 3 is equal to mod I Z plus 3 over I. Mod I is 1, correct? The length of I is 1, so it disappears. I multiply top and bottom of 3i by its conjugate, and it will give me Z minus 3i Is it correct? Yep. Okay, now after we have settled and tidy things up, we're going to plot the circle and the perpendicular bisector, but keeping in mind the shaded region onto the argon diagram. Okay, so copy already, because I'm going to show you the argon diagram next. Okay, this is how it looks like. Don't care about the line first. I'm more interested in the shape of the circle. How come 1/4 is missing? The reason is because if you look at your perpendicular bisector, this is your perpendicular bisector. This is like a perpendicular bisector, right? So the region is inside is actually here, right? Correct? That's on that side of the perpendicular bisector plus the circle. Therefore, the overlapping region will just be the circle itself. Okay? So let me erase this. Thomas, where are you? Okay? Now, let's go on. I'm going to take away whatever I've marked there because I need you to solve the next part. Okay? So, let me take this away first. And then I'm going to talk about how we continue on when they say find the range of z plus 1 minus I. So, they want you to find a range of this. So, they want you to find a range of argument z plus 1 minus I. They want you to find a range of that. So, range of that. So, simplify first. Okay? Every time they want you to find range of something or certain interval, first locate where is the negative 1 plus I. In this case, is here. Correct? This is the range. So Z means where your complex number is, which is your locus. Z. This is where it's operating. Find me the greatest and the least value of that. So what happens is that you know that first of all, when you have argument, you must first draw the positive real axis. Right? This is my positive real axis. The largest value would be here, right? This is my largest angle, right? Right? Because that's the tip where it ends. The green line will be my largest angle. And my smallest angle would be where E goes and join F as a tangent. This is my smallest angle, alpha, which alpha you expect it to be negative. Okay. Now let's focus on theta first. Okay, we'll deal with theta first, then we'll deal with alpha. So let me take this off. How do you deal with theta? You see this is a triangle, right? A right angle triangle. The distance is 2 units here. And the distance here is, if this is 2 and this is negative 1, it will be 3 units. So tangent theta is opposite over adjacent. Right? So theta is equal to 0.588. Okay? Are you very tired? Only one more line. See, I'm still on time. Hey, finish the latest, end the fastest. What did I just say? Never mind. Okay, let's go on to finding alpha. Okay, let's see alpha. We know that this is 3 units. We know that, right? Now, this part is actually the radius of the circle. What's the radius of the circle? Right? 2, right? Okay. So, sine alpha is opposite over hypotenuse, and therefore alpha is equal to 0.730. Correct? But be careful, when you want to find the range, alpha is actually a negative value. Okay, likewise, theta is always a positive value because it's going with respect to the positive real axis. So therefore, the range of argument z plus 1 minus I is negative 0.3730 inclusive. Okay, that's the answer.